Bismillahirrahmanirrahim. Assalamu alaikum, students. How are you? I hope everyone would be fine. In the last lecture, we talked about the binomial distribution, a distribution which consists of the two resultant outcomes. That was the binomial distribution. Today, we will discuss about the hypergeometric distribution. In the last lecture, in the binomial distribution, the trials were independent. And now, if you talk about the hypergeometric distribution, here the trials would be dependent. Hypergeometric distribution is also the type of the probability. It is also relevant with the discrete data or discrete distribution. If we talk about the discrete distribution or discrete variable where there is gap, absolute values would be there, positive values would be there. We'll discuss about the hypergeometric distribution. If we talk about the probability, as we know, probability from the probable chance variation. If we talk about the probability, it is the branch of mathematics which is concerned with the description of how likely an event is to occur or how likely it is that a proposition is true. Whatever the statement has been given, we have to verify, we have to prove whether it's a true one or the wrong one. If we talk about the answer of the answer of probability always lies between 0 to 1. If we talk about the answer becomes 0, that means impossibility of the event. The event can't occur. For example, 7 and 8 can't occur from rolling a dice on the same pattern. If the answer is 1, that means there is 100% existence of the event. If the answer becomes closer to 1, reliability or the occurrence of the event will take place. Here the chances of the event will increase. And if we move towards 0, it shows that the chances of occurrence that is decreasing. We are moving towards 0 probability. Probability chance variation. Then, if we talk about the probability concept, it always represent the likelihood of a given event's occurrence, which is expressed as a number between 1 and 0. As I told, the answer of probability always lies between 0 to 1. 0 to 1, 0 impossibility, and 1 means 100% existence of something. For example, if you say I study 26 hours out of 24 hours, it isn't possible. You can maximum study 24 out of 24, the answer would be 1. And if we talk about you aren't going to study, that means 0. And if you say that you study negative 5 hours, it isn't possible. So the answer of probability always lies between 0 and 1. And zero point 0.5 considered to be a equal chances where we can move towards the higher side or from the lower side. Very simple example is the passing criteria of the student is 50%. So if we talk about the 50%, it means we can't consider a student as a good student or a bad student. It is just the average student. He got the 50% marks or just the passing marks. If he'll move towards 100, towards 80, towards 90, that means he is a good student, and he is moving towards 30, 40, 20. He is considered as a dull student, or he is not the capable, isn't having the ability to pass. That means the chances of success becomes lesser when he moves towards 0, and the chances of failure decreases when he moves towards 1. It means that 1 represent the strong probability and 0 represent nothing would be there. What students will learn from today's lecture? What would be the learning outcomes? First of all, student will come to know how we can differentiate between binomial distribution and the hypergeometric distribution. They'll be in a position to discriminate between independent and dependent events. Then they'll come to know how the answer of the hypergeometric distribution exists and how we can interpret the results. Then they'll come to know regarding to the mutually exclusive events, then experiment, sample size, population size, or then they'll be in a position to understand the hypergeometric distribution and how it relates to a normal distribution. Then they'll come to know the probabilities for the hypergeometric distribution on our table. Then the students will be in a position to understand when you would use a hypergeometric distribution, the conditions of the hypergeometric distribution. Now, come to the distribution. What is the hypergeometric distribution? If we talk about the hypergeometric distribution is a discrete probability distribution where we describe the probability of success in draws when the samples population would be drawn without replacement. If we talk about samples drawn without replacement or population drawn without replacement, when the samples are not remixed in the population before drawing the next sample, whatever has been taken out that wouldn't be remixed in the population, that is known as the sampling or a sample without replacement from a finite population. Here the word finity has been used. That means the limited population. Unlimited conditions wouldn't be there. Unlimited liabilities wouldn't be there. That means limited concept is there. Limitations are there. Limited population is there. We have to draw the samples from the limited population. Then hypergeometric distribution that also contains exactly objects with that feature where each row is either a success or a failure. We can discuss the hypergeometric distribution both regarding to success and the failure. How do we come to know we shall apply the hypergeometric distribution? If the statement is given and the focus is being done on a specific item and a specific term, then we shall apply the hypergeometric distribution. Or when the trials would be dependent, the experiment would be dependent. Here the trials would be independent, but the results drawn that would be dependent. The probability of each trial would be different from the other. Probability of success does not remain same. In the hypergeometric distribution, it varies from trial to trial because here the term dependency has shown dependency. That means if independent variable would be affected, then automatically dependent variable would be affected. It means that reliability that is not independent, that is dependent. If independent would change, dependent would change. The dependency of events can't represent the same return, the same output, the same result. So, probability of success varies from trial to trial. Then, regarding to probability distribution, concerned with hypergeometric distribution, or simply we can say that in this lesson, the students will be in a position to understand the concept of hypergeometric random variables, hypergeometric experiments, hypergeometric probability, and the hypergeometric distribution that are correlated or related with one another. What notations we are going to use in the hypergeometric distribution? First of all, every individual, every student have to keep in mind the given notations while solving the hypergeometric distribution. First of all, the capital N would be there. that will represent the population. As in stats, we have learned n is used to represent the population size. So the number of items in the population that would be represented with the help of the capital N. And the second term would be K. Either you can write with capital or you may write with small alphabet K. K is the number of items in the population that has been taken as a success or that has been classified as success. If you talk about the small n in stats, in the first lecture, we talked about small n is always used to represent the sample size, the sample of the data, the minor part of the data, representative part of the data. Small n always represent the sample size, the sample data, whereas x represent the successive trials, or x has been classified as the probability of success which is going to be asked, which you are being directed, you have to find, that is known as the x. X is what is being asked from you to calculate, that would be the probability of success regarding to the x. Then K, Cx, C stand for the combination rule. Then we shall apply the number of combinations of K things taken x at a time. X at a time, as I told, x has been directed. X has been told to you to what to find. So x is successive trials, or the trials or the probability we have to find, that is denoted with x. And in all, the hypergeometric distribution would be written as h, x, n, and k. Here n, and k, these are the parameters of the hypergeometric distribution. There are the three parameters in hypergeometric distribution, whereas in the binomial distribution there were the two parameters. In the binomial distribution, n and p, n and p were the parameters in binomial distribution. Whereas in the hypergeometric distribution, there are the three parameters. One is the capital N, second one is the small n, and the third one is the k. In the hypergeometric probability, the probability that an n-trial hypergeometric experiment will result in exactly x successes. Exactly x successes, that means whatever has been asked to calculate from the given question, from the given statement, that is known as the x. When the population consists of n items, if we talk about the n items, that is the population size, the limited population, the finite population, where k of which are classified as success. Here k has been used as the probability of success. There is a difference between k and x. K represent the probability of success to whom the focus has been done, that is known as k. And out of k, whatever you are going to find, that is known as x, that is known as the successive trials, or the resultant outcome you want to find, that is known as small x. Now, what the properties the hypergeometric distribution has, you have to keep in mind the properties of the hypergeometric distribution. First of all, mu of the hypergeometric distribution, that would be equals n k divided by capital N. Small n k divided by capital N. Small n is the sample size multiplied by k, that is the probability of success that has been taken, that has been identified or classified. Whereas n, that is the population size or total population which has been taken from the given experiment, from the given statement. Then the variance of the hypergeometric distribution, that would be nk divided by n multiplied by 1 minus k over n. 1 minus k over n, then multiplied by capital N minus small n divided by capital N minus 1. Here the term variance, variations, scatteredness in data. If the answer of variance or standard deviation, that would be the greater one, the larger one, the data reliability would be the lesser one because it represents more variation, more scatteredness in the data. If the answer of a standard deviation or variation will be least, it represent data reliability. We can depend upon the given statement, given data, because there is lesser variation in the data and we can rely on the information. Regarding to the hypergeometric distribution, as I told in the start of the lecture, the trials are dependent and they are the different. It means that the conclusion of one trial does not depend upon the conclusion of the other trials, and all the trials have different probability. As I told, when one variable depends upon the other variable, we can't say that the resultant outcome would be the same. The resultant outcome would be different at every next trial. The probability of success does not remain the same. The probability of success varies from trial to trial. We can't stay stagnant or we can't stay fixed at a specific level. We have to move on, we have to change the probability, we have to bring the change regarding to independent variables. If independent would change, then automatically dependent would change. Now come to the point regarding to the formula of the hypergeometric distribution. Before explaining the formula, let's have a look on the hypergeometric distribution. A hypergeometric random variable is the number of successes that result from a hypergeometric experiment. Hypergeometric experiment, an experiment. When it is being performed, it gives different result at each time. That is known as the hypergeometric experiment. The probability distribution of a hypergeometric random variable is called a hypergeometric distribution. Whatever the probabilities we will represent of the hypergeometric experiment, the formula, the technique we shall apply, that is known as the hypergeometric distribution. Now come to the point regarding to the hypergeometric formula, how we can represent the given information into a specific sort of formula. Suppose a population consists of n items, k of which are the successive or the success rate, whereas a random sample would be drawn from the population that will consist of n items, x of which are the successes. Whatever is being asked to calculate, being asked to find, that is known as the successive trials or the x. Here is the formula to calculate the probabilities of hypergeometric distribution. The formula is hx n n k, which is equal to kcx multiplied by n minus k, c stand for the combination, n minus x whole divided by, this whole term would be divided by ncn. Capital N is the population size, C is the combination, whereas N is the sample size. If we talk about the combination in the last lecture, in the binomial distribution, before the binomial distribution, the basic probability concepts, we talked about the combination. It is the arrangement of objects, arrangement of data without a specific order when the sampling is done without replacement. That is known as the hypergeometric distribution. Now come to the mean of the hypergeometric distribution, that is small n multiplied by k whole divided by capital N, the population size. If we talk about the variance that would represent nk multiplied by n minus k or into n minus n divided by n square into n minus n1. You may write the formula in the given format, or you may write the formula in the given format. Regarding to the variance, it's up to you how you may write. You can do that. The result wouldn't differ. Regarding to the formulas of variance, either you can write the formula in this form or you can write the formula in this form. Now, here is an example. Suppose we randomly select 5 cards without replacement from an ordinary deck of playing cards. What is the probability of getting exactly 2 red cards, hearts or diamonds? In the last lecture of probability, we talked about the cards. There are 52 cards in a well shuffled pack of the playing cards, 52 cards. And there are the two colors of the cards. One is the red, and other one is the black. In all, there are the 52 cards. 26 would be the red cards, whereas 26 would be the black cards. If we talk about the red cards, the focus is upon the red cards. Keep it in mind, the focus is upon the red cards, exactly two red cards. It means we are directed, we have to find the red cards, the probability of red cards. It means our interest is about the red cards. So probability of success, that would be the k, that would be equals to 26. That would be equals to 26. Probability of success k, that would be equals to 26, because we are being directed to find the red. The focus is upon the red cards. There are in all 26 red cards, and 5 cards had been drawn, that has been taken out. That is the sample size small n, which is equal to small n. And you're being asked to find exactly 2 red cards. It means successive trials, or the value of x, that would be equals to 2. It is equal to 2. Since 2 of the cards we select are red, it means if 5 cards are in your hand, out of these 5 cards, 2 would be the red. It means that remaining 3 would be the black cards. For your ease, for your convenience, hearts and diamonds has been written. There will be the 13 heart cards and 13 diamond cards. 13 plus 13, that means 26 cards. As I have written, k is the probability of success, that is known as 26, or the value of the red cards, that is 26. Now we have to insert the values in the given formula of the hypergeometric distribution. Let's have a look. KCX. Here k is the 26, c is the combination, then x is the successive trials, which is equal to 2. Whereas n minus k, it is the probability of failure. N minus k, it is the probability of failure which has not occurred. We are not talking about the black cards. So 52 minus 26, that is equal to 26. C, n, the sample size was 5, minus x, small x was 2. So 5 minus 2, which is equal to 3. That means 2 would be the red cards, whereas 3 would be the black cards. Then overall, regarding to 52, so 5, n would be the 52, see the combination, and n is the representative part, which is equal to 5. So we shall solve the question by using the scientific calculator. If you don't have the calculators, then you may apply the combination rule, but that would be the pathetic one for you to calculate the big values. So it is convenient to calculate by the scientific calculators. Again, I repeat, suppose we randomly select 5 cards without replacement. Whatever has been selected, that means your sample size, small n, which is equal to 5, from an ordinary deck of playing cards regarding to the jack of or you can say the pack of cards. What is the probability of getting exactly two red cards? Here the focus is upon the red cards. So our probability of success would be considered as red cards. That would be equals to k, which is equal to 26. Then the focus is upon the two. We have to find two out of these red cards. It is the successive trials, which is equal to 2, since two of the cards we select are the red cards. So we plug these values into the hypergeometric formula, so we will find the result. How we will put up the values? Here k is the probability of success, which is equal to 26, whereas c the combination rule, and 2 the sample size of 26, which is equal to 2 regarding to the successive trials, 26c2. The remaining 26 cards are the black cards, and the remaining 3 cards would be the black cards. It means we have to complete the sample in each case. On in every situation, we have to complete the sample. Sample was 5, 2 are the red cards, and then the remaining would be 3 of the black cards, divided by, in all, we are talking about the population. There are the 52 cards, and in all, we have drawn the 5 cards out of 52. 52c5. Then we'll find the probability, which is equal to 0.32513. It will represent the probability of the hypergeometric distribution. Let's have an example. Another example. There is another example regarding to a deck of card contains 20 cards. Now we are talking about just 20 cards, 6 red cards, and 14 black cards. 5 cards are drawn randomly without replacement. What is the probability that exactly 4 red cards are drawn? First of all, you have to gather the information, you have to focus upon the question, what is being asked, what has been asked, and where the focus has been put up. Let's have a look. There are 20 cards. It means capital N, which is equal to 20. 6 red cards out of these 20 cards, 6 are the red cards and 14 black cards. It means out of these 20, 6 are the red cards and 14 are the black cards. 5 cards are drawn randomly. It means 5 has been taken as small n randomly without replacement. What is the probability that exactly 4 red cards? Now the focus is again upon the red cards, and in all there are the 6 red cards. If these 4 cards will be red, then obviously they'll be out of 6 red cards. And the sample was 5, and remaining 1 card would be the black card, which would be out of 14 black cards. Now let's have a look on the formula. Kcx n minus kc n minus x divided by ncn. The probability of choosing exactly 4 red cards is what? Let's have a look. That means 4 red cards would be there, whereas 1 black card would be there. If 4 red cards would be there, they'll be out of 6, and 1 black card, that would be out of 14 black cards. We have to complete the sample in every situation, in every condition. Otherwise, we can't make the solution. Using the combination formula, the problem becomes hypergeometric formula. As I told earlier, the 4 cards would be out of 6 red cards, and from the given formula, here you will see n minus k. N was the 20. 20 minus k is the probability of success, which is equal to 6 red cards. 20 minus 6, which is equal to 14. C. 14 is again the black cards. That means if the red card is not there, the black card would be there. The black card would be out of 14 cards. 14c. N is 5 minus 6, which is being asked, that is 4. 5 minus 4, that is equal to 1. 14c1, which has been written over here 6c4, then into 14c1, overall 20c5. So we will find the solution through the process of the scientific calculator. There is another example regarding to the hypersymmetric distribution. A small voting district has 101 female voters and 95 male voters. A random sample of 10 voters is drawn. What is the probability? Exactly 7 of voters will be female. Now, the focus is on the female. It means that females are the as will be taken as the symbol of success. So there are 101 females. It means if 7 females would be there, they'll be out of 101. And the sample of 10 has been taken. That means if 7 would be the female, then rest of the 3 would be the male. They'll be out of 95. We have to focus upon the terms, on the question, on the information, what has been given, and what is being asked from you. Again, I repeat the question. A small voting district has 101 female voters and 95 male voters. It means 101 are women, whereas 95 are men living in a locality or in a district. A random sample of 10 voters is drawn. If 10 people are chosen at random, then what is the probability? Exactly 7 of the voters will be female. If we select 10 members, then what is the probability that exactly 7 out of these 10 would be the female candidates or female voters would be there? If we talk about the female voters, if they are the 7 in all, we have taken the sample of size of 10, the remaining 3 would be the men, they'll be out of 95. So if we go to the towards the solution, the total is 196. Total is the 196. Let's have a look regarding to the formula. The formula is kcx into n minus k c small n minus x. One step I will look at over here. That will be regarding to the formula, so that it would be easy for you to understand the term. How the values have been inserted over here. Let's have a look how we are going to insert the values. I have written the formula of the hypergeometric distribution. Let's have a look again. Here is the formula kcx. K is the probability of success. Probability of success is regarding to the female voters, which is equal to 101. And what is the probability? Exactly 7 of the voters will be female if the random sample of 10 voters is drawn. If 7 women will be there, they'll be out of 101. 101 C7 multiplied by capital N was 101 plus 95, that was 196. Minus K is the female voters. So 196 minus 101, which is equal to 95. 95 C. N, that was taken as 10, and X is the successive trials, which are equal to 7. 10 minus 7, which is equal to 3. 95 C3. 7 female voters have been taken out of 101, and remaining 3 would be out of 95 men. Whole divided by 196, that is equal to 101 plus 95. The total voters in the locality, in the community, in the district, they were 196 C, and the total sample size was taken, there was 10. 196 C 10. You will find these values by the scientific calculator, and the end result is 0.130. It is the final result. If you find in the percentage, you will multiply the given value by 100. You will come to know there is only 13% chances out of 10 voters, exactly 7 would be the female voters. Here is the elaboration. 101C7 is the number of ways of choosing 7 females from 101 end. 95C3 is the number of ways of choosing 3 male voters from 95. Then, overall, there were 196 voters in all. That was including female and male voters. The was is equal to 196, and overall 10 voters were chosen at random. So 196 C 10, which is equal to again the selective portion. The selection term is 10 out of 196 overall data. That's because of 7 over 10 voters are female and 3 over 10 voters are the male. There is an example regarding to the hypersymmetric. There are 10 black marbles and 10 white marbles, out of which 5 marbles are being chosen. Here, 10 black marbles and 10 white marbles are there, out of which 5 marbles are being chosen. It means the sample size is the 5. Find the probability that there are 2 white marbles in them. The focus is upon the white marbles. The white marbles are, they are the 10. These two will be out of these 10, whereas the remaining 3 marbles will be the black marbles. The remaining would be the 3 black marbles. The focus is upon the white marbles, so probability of success is white marble, which is equal to 10. So the probability of K, which is equal to 10, and the number of successes, that is capital N, which is the combination of 10 plus 10 total population, the total data which has been given, the total population, the total values, the total number of items which has been given, which is equal to 20. So number of success in the given, that is 20, sample size which has been taken, which is equal to 5, and the successive, that is equal to 2. Here small x is equal to 2. Small x, not the k, here the small x is equal to 2. Here the small x, which is equal to 2. Now we'll insert these values into the given formula. The probability of getting 2 white marbles, the formula is kcx n minus k c n minus x whole divided by ncn. Let's have a look and find the solution over here. Here k is the selective part, which is equal to white marbles, which are 10, 10 c 2. Take a 2 is there, which has been focused. 2 should be the white marbles, 10c2. Then the remaining term would be there, n minus k, 20 minus 10, which is equal to 10c. 5 minus 2, which is equal to 3. The remaining term would be out of black cards. Then ncn, total n is there 20, and the 5 is the selective rule, or the selection is there. So we'll insert the values over here. Instead of writing n, we'll write 20. That will be 20. C small n is the 5. We'll write the 5 over there. So 20 C5 is the total population. Is the total population we are inserting, and then the sample size which has been taken as 5. So we'll write down the values of sample size, which is equal to 20C5. We will solve by the scientific calculator, or you may solve with the help of the combination rule. Next one is, out of 100 students qualifying in exam, 10 were drawn randomly. If 35 out of 100 qualified students are female, then find the probability that 6 out of 10 chosen are females. Again, the focus is upon the females. It means our probability of success K, that would be the females. If 35 out of 100 qualified students are female, it means female students are 35 and remaining 65 students will be the male students. And 10 were drawn randomly. It means the sample size is 10. Small n is equal to 10. First of all, the first step you'll have to do, you have to gather the information. You have to collect the information. What sort of information is given? What values are there? What is capital N? What is small n? What is small x? What is k? When you'll find the values, then it wouldn't be difficult for you to insert the values in the given formula. Now, I repeat the question. Out of 100 students qualifying an exam, 10 were drawn randomly. 10 were drawn randomly, 10 were selected as an independent students. If 35 out of 100, if 35 out of 100 qualified students are female, if 35 out of 100, it means if 35 students are female, then the remaining out of 100 that are 65, they'll be the male students. Then find the probability that 6 out of 10 chosen are females. It means out of these 10, 6 would be the female. It means small x which is equal to 6, small n which is equal to 10. Now capital N which is equal to 100, sample size which is equal to 10, number of successes in n which is k which is equal to 35. The focus is upon the female candidates, female students. So they are 35, k is 35. Number of successive in sample, that is regarding to x, it again has been written as k, it would be as x, which is equal to 6. It is equal to 6. Now we'll insert these values into the given formula of the hypergeometric distribution. Now, probability of getting 6 female students. Here the 2 white bubbles was given. Here is the 6 female. Female members or students are there. Female candidates or students are there. 6 female students. So we'll insert the given information into the formula. Probability of capital X equals small x, which is equal to kcx into n minus k cn minus x divided by ncn. Here k is the 35, which is out of 100. 35 c6 into 100 minus 35, which means the failure, and minus k, which has not occurred. They are the men. They are equals to 65. C 10 minus 6 x. If 6 female are there, the remaining 4 would be the male. They'll be out of 65. You may write or you may add the term one more step over here for your clarification. How we'll find the data over here. Let's have a look. What we'll do, we'll find the solution regarding to the given questions. Here we'll put up the value regarding to the 65. Here 65 would be there. Then the remaining 10 minus 6, which is equal to 4, would be there. It shows 65 C4. It means 4 male candidates, 4 male students would be there out of 65. If 6 female students were there, the remaining 4 male students will be out of 65. Then we'll find the solution and the end result is 0.063 If we find the answer in percentage, then we shall multiply the given answer by 100. The answer would be 6.3. It means there are only 6.3% chances that out of 35, exactly 6 female students will be there out of 10 students which have been selected. Now it's student turn. They'll solve the questions, determine the probability distribution for the number of white beads among 5 beads drawn at random from a bowl containing 4 white and 7 black beads. Then compute mean and variance. Check the result by using the formula. Major difference between binomial distribution and the hypergeometric distribution. If we talk about the binomial distribution, it is also the discrete distribution. Hypergeometric is the discrete distribution. But in binomial distribution, probability of success remains the same throughout the success. Here the trials are independent, whereas in the hypergeometric distribution, trials are the dependent, whereas probability of success varies from trial to trial. It does not stay constant. Then you'll have to apply the formula of mean and variance regarding to the hypergeometric distribution, that is equal to n k over n, or regarding to variance which is equal to n k over capital N multiplied by 1 minus k over n or into then capital N minus small n divided by capital N minus 1. You will apply the formula of the variance. Second question 12. Vegetable cans are there out of the same size have lost their labels if the it is known that 7 contains tomatoes and remaining contain corn. If 5 cans selected at random, what is the probability that all contain tomatoes? 5 or more contains tomatoes, then exactly 3 contain tomatoes. You have to find the solution. In the next lecture or in the interactive lecture, we will discuss upon the student activities. The answer should be there. If you feel any difficulty in calculating the questions, then you may ask from me in the interactive session. That's all from my side regarding to the hypergeometric distribution. In a nutshell, I would like to summarize the term what we did today. We came across the concept of the discrete probability distribution. That was the hypergeometric distribution. There was a hypergeometric distribution. We came to know what are the properties of the hypergeometric distribution, under what conditions we apply the hypergeometric distribution, what is independent and what is dependent variables or experiment. Then we came to know how we'll find the concept of hypergeometric mean, hypergeometric variance. Then we came across the numericals of hypergeometric distribution. We came to know the difference between binomial distribution and the hypergeometric distribution. Inshallah, in the next lecture, we'll talk about the Poisson distribution, that is also the discrete probability distribution that is correlated with the road accidents, the specific number of items that has been taken from the sample. We'll focus upon the Poisson distribution, that is also the discrete. So it is recommended and directed to the students. Please go through your notes, your handouts, even from your book, even from the PPT slides, or from the net. You can sort the term regarding the Poisson distribution. Whenever you'll go through the lecture, you'll be in a position to ask the questions in a proper way. There shouldn't be any hurdle or problem while asking the questions. Inshallah, we will proceed regarding to the Poisson distribution in the next lecture. Until then, take care. Allah Hafiz. May Allah bless you, keep you in safe hands. Okay. God bless you. Allah Hafiz.